Okay, let's go. Ready to start. Well, what can I say? Welcome to this second edition of the DfMay. We organized this conference last year, and we were very happy at the end of the event. So we decided to organize this year as well. It was a big effort, big investment of time, and we made it. We're quite nervous. We're all quite nervous today because we have we have 5 great speakers, and they will talk about their experience that we share with us. They were a very precious experience about using a mass timber in different areas of the world, and this is amazing to it is amazing to have gathered all those people together here. I'm Franco Piva. I'm the director. I'm the founder of the company, of the engineering firm Ergodomus Timber Engineering. Next to me is my colleague who is helping me to organize these events, and he is the guy behind our LinkedIn profile. He is also the one posting, creating the newsletter, etc., to keep in to stay in contact with all of you all over the world. So I will start with my presentation to say something about today. And the first slide is a great picture, or at least I like it very much. And I created in a few minutes using the artificial intelligence. I always like to push the boundaries and to experiment, to test something new. And I just input create an amazing mass timbering conference with a screen on the background. So please, during this presentation, imagine to be in this room, looking at the attending the conference and looking at the presentation of the speakers. This is the timeline we will have today. We are a few minutes late, but I prefer to leave you to start a couple of minutes later to have more people. They are joining from all over the world. And we will have, after my short introduction, we will have 5 speakers. It will be Kenny Holm from Denmark, then Leander Moons from Kenya, then Craig Applegath from Canada, and then 2 guys from the US, Ricky McLean and Jerry McCogie. And then at the end of their presentations, we will have a roundtable, a Q&A time. So feel free to post all your questions on the LinkedIn platform. We will try to pass all those questions to our speakers at the end of their speeches, and all the questions will remain on LinkedIn, and we will try to reply as soon as we can, or all our LinkedIn community will be able to take those questions and to reply. I hope this conference will start a very interesting conversation, a very interesting discussion among us to create some new ideas and to convince, let's say, you to use more mass timber for the next projects. What I would like to do to make this presentation more interactive is, if you can please join on LinkedIn, or if you can click on LinkedIn and then type, where are you from? I know there are people from Italy, from Scandinavia, from Canada, US, Germany, Austria, Swiss, but please, you're more than welcome to type the country you're from on your computer using the LinkedIn platform. Just a few words about who Ergodomus is. Ergodomus is an engineering company. We are based in Italy. I created the company in 2007, and now I'm very happy and proud to run this company together with my business partner Stefano, who is not here today, but he is working very hard on a deadline in the room next to me. And together with me and Stefano, there are 6 great guys working very, very hard, and we are one of the biggest timber engineering firm, at least in Italy. So it's not me. It's not just me. It's not just Filippo next to me, the guy you saw before, but 6 more guys are working very, very, very hard to make all the projects happen. We engineered more than 300 timber buildings all over the world, and we are at the moment working in many different time zones. So we go from +10 in Australia, down there in Australia, to -9 on the west coast or coast of US and Canada. It is not easy, it is not a miracle, but I will tell you later what is our secret, we can call it. We work with producers, designers, developers, investors, and general contractors. These are our clients, and together with them, we'd engineered many different projects offering basically 4 different services: value engineering, structural analysis, DfMA, and we will speak a lot about DfMA today, and project management. All those projects, and now I tell you what our secret is. All our projects have something in common. They all have a common thing, which is the digitization, which is the digital model. And I really like to use this metaphor of having of using what you're familiar with in the Matrix movie, these letters moving from the top of the screen to the down of the screen. So we see this, we see an endless sequence of numbers, of letters, but behind this digital layer, there is the real building. And when I say real building, real structure, I mean more than 300 mass timber buildings all over the world. We even engineered once a floating timber structures for the Biennale in Venice. We engineered structures in US, Canada, Australia, and I know that one of our biggest client is here, which is Paolo from Italy, is living between Australia and Italy together with his business partner Adam, and I know he is attending this event as well. So talking about the digitization and how we made all those projects possible. The key word is DfMA, Design for Manufacturing and Assembly. And I'm sure that Craig later will also say plus disassembly. So we also need to start thinking about how can we disassemble all those structures at the end of their life. DfMA has something behind, which is the BIM. We're all familiar with this acronym as well, Building Information Modeling. But as a friend of mine from South Africa, Emma, who should be also here today with us, once told me, BIM is different than BDM, Building Disinformation Modeling. So we need to move to adopt the digital model, to adopt the digitization for our structures. We need to push the boundaries, and we need to go for BIM instead of BDM. Just 3 more slides before moving to the next, to the first speaker of today. When I say digital model, I mean structures, I mean drawings like this one. This is a project we've been working on for many months. It's going to be one of the biggest mass timber office buildings in the world, in Europe. It will be about 30,000 square meters, which is about 300,000 square feet. And on this project, we had the opportunity to implement the most advanced digital technologies. So each element in the beam model has a name. We can see the assembly sequence. We can see who is the producer, in which truck these elements will be loaded. We can check everything, and we can share this model weeks before having the timber elements on site. We can share this with the designers, with all the other designers, with the developers, with the builders, so everyone knows exactly what they will get on site. No matters how complex the elements are, no matters how big, small they are, they can check, they can deeply check everything, and then they can say, okay, this is what I want to get on site. And from the digital model, we quite quickly move to the real element, to the real 3D element, which will arrive on site a few weeks later. So as I said, no matter how complex the details are, every single detail is made in 3D. And to wrap up, this is the most time-consuming part of our job, because we cannot say it will be something similar to this. Since we create the files for the CNC machines, everything must be much, much more than perfect. Because if we draw something wrong, you will get something wrong on site, and we don't want to have problems on site for sure. The goals of today, are just some of the goals for today. Is the building industry ready for the mass timber revolution, mass timber evolution? Why the digital model? Can we improve the way we design our structure using a DfMA approach? I would like the people, the attending people from all over the world, to be less skeptical about about the use of mass timber for even for the high-rise building. And then one of the acronym I really like is what you draw is what you get. Digital model, production with CNC machine somewhere in the world, and then a very quick assembly without problems. So that is my short introduction. I don't want to speak more than this, and I really want to say one last sentence, which is this sentence was written by Albert Einstein. The measure of intelligence is the ability to change. So I really believe, thanks to the mass timber, thanks to timber, it is really changed for us as human beings to change. We have now today the chance to change, and I hope that this conference will will uh, will convince someone more to change the way they build or the way they design. So, time to introduce the first speaker for today. The first speaker is Kenny Holm from Denmark. We met with Kenny many years ago, and we met in Copenhagen. I still remember that day we had a beer together in a very nice pub, and we started talking about mass timber. We started talking about, wow, what about working together? What about trying to change the world, let's say? So we created a few days later the Game Changer Club, and we hope also the DfMay, this conference, will help us to develop this program. As I said, Kenny is based in Denmark. He was a production manager at Word. He worked also for the company Rotoblas. Now he is running his own company, Holdbar, and he is doing great. We're working together on that huge project. We're working together with him, and I don't want to talk anymore. Otherwise, they tell me that, well, Franco, you're at Chatterbox. So stop myself. Kenny, please let us share with us your experience with mass timber.
Well, thank you, Franco, and to let all of you out there stay in the belief of Franco's beautiful scene, I've put myself in front of this wooden wall to let you stay in the belief of this beautiful concert hall. Well, today I have three things I would like to show you or talk to you about. And let us see here. I called my presentation Wood, a building material of the future from a Scandinavian point of view. And it has to do with the fact that wood has been a material of the building industry for many, many years, but it seems that we have, in the past 5 or 6 or 7 decades, forgotten how to use wood, especially when it comes to bigger constructions like mass timber constructions and etc. Of course, for the homeowners, the small single-family homes, it's still a thing to do. But in general, for the big construction sites, big constructions, we have forgotten how to use wood. So this is putting wood into a new perspective. Now I have to click here. Yeah. Just shortly about me, I'm a skilled carpenter, and reading this out, I realized I should have been writing I'm a trained carpenter as profession. And since then I've taken some my extra education and so forth, and now I'm here where I am. I've also been, as Franco said, a product manager at Würth for the building material area that has to do with wood constructions. Then I was chief of products at a large sawmill here in Denmark, where I worked with impregnation of wood and fire retardant of wood and so on. Then I changed to market manager at Rotoblas, building up that brand in Denmark for some years. Then I founded my own company. It's called Holbar. I have this together with a partner of mine today, where we do consultancy about wood constructions and how to use wood and what possibilities are and on the market with wood. We try to keep on track on that anyways. Besides this, I'm a market manager for SBS, Södra Building System. Södra is a Scandinavian or Swedish-based company who produces mass timber. The agenda for today, since we do only have like 10 or 15 minutes to present here, I have to make it short, and that's not my biggest advantage to present short. But anyways, I'll try to keep on track. First of all, I would like to show you some projects that has been done here in Denmark or is on the way, just to show you how the trend is moving and how fast it's actually going. Then I will talk a bit about building regulations. I know that we have people here from many parts of the world, and building regulations may vary quite a lot, but at least in Denmark and in Scandinavia and in general, we try to have somewhat similar building regulations, and I would just like to present them and to present what it does on the market and on the market behavior. Then, as a loop on that, I would talk to you about this, what we call pre-accepted building solution here in Denmark, which tend to be a sleeping pillow for approved building methods, claim or meaning it's kind of the easy way for engineers, for architects to choose, because it means they don't have to think a lot for themselves in general. Because they can just take a off-the-shelf solution and present that, and we as a supplier, we as kind of innovative engineers and so on, we have a problem with that on the market. But before we set sail, I would like to ask you this question. Why are we talking about wood? I don't want any answers right now anyways, but I want you to think about it and sum up why you believe we are talking about wood. So, projects that has been done here in Denmark and in Scandinavia. I've chosen mainly Danish projects. I could have chosen some Swedish or Norwegian even projects in this presentation, but the Norwegian projects I would like you to see. I believe many of you already know because they are a couple of years old. We have some Swedish projects also that is very interesting, but still many of them are really well known out there in the market, is my gut feeling anyways. So I'll kind of leave them be and present what is in my market, my home market here in Denmark. If we take this project, this is where it kind of all started here in Denmark. It's called Lisbjerg Bakke, and it's from the architectural firm Vandkunsten. This project was finished around 2018 and was, roughly speaking, 4,100 square meters big. At that time, this was a huge timber project in Denmark, and it was the talk of the town. Everybody was focusing on this project and how it was done and how it was kind of taking in different wood products from all over the European market and setting together in a new way. The project was actually originally started in 2014, so from 14 to 18, this project was realized. Then going on to today, we have this project, 3 tower, and this is a word game in Danish. 3 is wood, but kind of similar to 3, and there are 3 towers in this project, made by linear architects, and it's roughly 15,000 square meters. And I'm sorry for the American audience, I do not know the square footage of these projects, but I guess you can calculate them around yourself. This project is currently being built in the city of Aarhus here in Denmark, and supplied by an Austrian massive timber producer. Moving on, I have to use the right clicker here. We have this cobalt hub by 3XN architect here in Denmark as well. It's 20,000 square meters of a hub for robotic technology, based in the center of Denmark, in the city of Odense. That's where Hans Christian Andersen comes from. Then we have this, the project, the Marmormolen, and for the quick people out there, you will realize this is the project that Franco was showing in the beginning of the presentation, the 3D model. And I know Franco said it was a bit bigger, but it's because his square meters includes the basement that's made in concrete. But the wood part of this is 25,000 square meters of CLT and glulam beams and glulam columns. This will be an shared office space with a the first floor, the entry floor is kind of a public space where you have restaurant and also the cantina service for the building is located here. And it has to do with the fact that this building is located right in front of the waterfront in Copenhagen Harbor on the north side. It's the pension fund building this project and sponsoring it, you could say. Now you need to, here we have the wood hub by C.F. Møller architect. It's 31,000 square meters and located in Odense, as well as the other project, the Cobalt Hub. This project is kind of interesting, not only based on the fact that it's really big, but this is also where the the legislation board for building codes in Denmark is going to be located. So actually they decided to build a wood building based on many things, but also to prove that it was possible to do it within a reasonable budget. Before I end this presentation, I just want to say, moving from the Lisbjerg Bakken, that was 4,100 square meters in 2018, we had a period of silence, you could say, and then the other projects I've shown you here are being realized within the last 2 years. So this is how fast things are evolving here in Denmark. And from a historical perspective, just remember that before 2018, 2014, many of these projects weren't realized. We had some wood projects, we had some single family homes, of course, we had some row houses and so on being made as a module concept, as a stick frame buildings. But going into the height and so on is really from 2014-18 until now. And as I said, within the 2 last years, this is what happened. I'm sorry if I do not look into the camera all the time. It's because I made some notes and they are not visible on this screen where I'm sharing from. So I have to read out from the side. Also, regarding these projects, it's showing that all the big architectural firms are aware of the fact that we are going to use wood as a building material in the future. It also shows that all the big engineering firms are aware of the fact that we are going to use wood a bit more in the future. So it's a really interesting journey we are on. So about the regulations. In Denmark, we have the BR18. It says building regulation from 2018, you could say, but it's still valid and it's often updated with new stuff. The building regulation in Denmark, the BR18, sets the regulation on a general level for how we design and build buildings. It takes into consideration airtightness. It takes into, of course, then it takes into consideration when we build an airtight building, we need to kind of replace the air that is stored in the building. So now we also need to talk about ventilation and ventilation systems. And actually in Denmark, it's mandatory to have a ventilation system installed in all homes, no matter the size of the building. It also sets some regulation about fire safety and how we manage that and how we make sure that people can exit from the building within a short time frame. We actually do not consider saving the building. It might sound odd, but we are more interested in saving lives and not buildings, because buildings can be replaced or rebuilt. It sets some points about sound or acoustic performance of the building. It sets really, I would say, high demands in the acoustic performance of a building, so that you do not hear your neighbor snoring or walking on the floor or whatever it might be. It also sets some boundaries, you could say, about the daylight, or maybe not. Yeah, it is boundaries, you could say, about the daylight, how much daylight is in a room, and it's set that a certain area of a building should be glass, or a certain area of the building can be glass, nevertheless. So that's two ways of looking at on the same. It's two takes on the same matter, you could say. Thermal insulation is also a big thing here in Denmark. It has not to do with the harsh winters we have, because we don't. We have, in general, very mild winters. Of course, if you go to the north of Norway, they have very harsh winters, and also the north of Sweden or Finland, it has harsh winters. But this comes out of the oil crisis in the 1970s, 80s, where we had a high consumption of oil heating our homes in Denmark. And from that day on, you could say the building regulation was very strict when it comes to thermal insulation of buildings here in Denmark. And of course, one of the biggest companies in the world producing thermal insulation is a Danish company, so it might have something to say as well. The thing that we're missing today in the building code is a bit about the mental well-being within the lived space. Also, how does the built environment influence the mental being of people? As you see, I sit in front of this wood panel, and it makes me feel comfortable, you could say. Sitting in front of a bare gray concrete wall might have other influence or impact on me as a person anyways, and it will be different from person to person, but still, nevertheless, it would be interesting to take this approach in the future of thinking mental well-being in the lived space that we have. Also, and this we are starting to see change, and I'll show you within short, the impact on the earth that we are living on and the material that we are using from our earth, because we only have one. And it has been very popular the last couple of years to talk about Earth Impact Day. And I believe in Denmark we have Earth Impact Day in somewhere in March. So we need kind of 4 Earth globes to fulfill our demands in Denmark alone. And I think it's kind of the same situation in Sweden, Norway, and Finland. The building code try to be material neutral, stating it does not benefit, or it does not make it beneficial to use concrete or to use wood or to use steel. It kind of tries to remain neutral when it comes to the choice of material, you could say, for a building. But is it always a good thing to be material neutral? I am not sure it is, because this leads us on a path where it's just nice and easy to choose the material that we always work with. So, being a country that has been working with precast concrete for many decades now, this is kind of the solution we choose because it's safe, we are familiar with it, we are comfortable building with concrete and with steel in some degree. But as I said in the beginning, we have kind of forgotten to use wood. And since the building code does not favorize wood, we tend to stay with the concrete and steel, and this makes it kind of difficult to change the market. So we still have a bit to go. And of course, lobbyism from different parties are also a thing in Denmark. And based on the fact that we have been using concrete and stone wool for many, many years, the lobbyism is also a part of that world and has been for many, many years. So it's really difficult to change the culture without kind of... Okay, I need to close, I guess, yeah. Future scenario, I'll just wrap it up really shortly. This is how the market will be in the future here in Denmark. In 2023, that's where we are now in 2024, we'll set regulation for new buildings below 1,000 square meters and above 1,000 square meters. Below 1,000 square meters, we do not have any boundaries right now, but when it comes to buildings with above 1,000 square meters, there will be a limit on the CO2 emission for the building and the material that you use in the building. It will be 12 kilograms of CO2 per square meter based on EPDs, product-based EPDs. In 2025, we'll move to 10.5 kilos, but please note here, now it will be for all buildings, also residential buildings, single-family homes, etc., etc. Moving on to 27, 28, we'll go down to 9 kilos CO2 emission per square meter. And coming to 2030 will be around 7.5 kilos. These numbers are just temporary because they are meant to be adjusted in 2024 when we have some more facts on the table on how the buildings that we are building today is performing in the future. Then we have the low emission class that is here. That's not mandatory. That's for you to choose if you want as a building owner. And here we go to 5 kilos CO2 per square meter in 2030. That is the idea today, but this will probably be lower. It will most likely be lower. The risk here is that measuring can make you blindfolded. If CO2 is the only fixed point you have, you might risk missing out of the bigger picture because using more wood, meaning, okay, we store more CO2 in the building, so we have a smaller CO2 impact. But is this always the best? I'm not sure it is, because when wood is incinerated after end of life, we will emit CO2, and we only have a limited kind of wood supply available. So we need to stretch the material a bit to cover all the buildings that we will like to build in the future. And I would just say rules are not better than the persons implementing them. And it does not take away the responsibility of thinking yourself. In Denmark, we have the pre-accepted building solution, aka approved building methods. And this is how building regulation clashes with how we want to build, because you might see the two buildings on the picture here. One is a steel frame and one is a timber frame. Business as usual is the steel frame structure. And then the thing we want to build is the timber frame structure. But it is not business as usual, and the building code is kind of not taking this into consideration, because one building to another might seem similar, but in regard to building codex, they are not. Even though the building code is material neutral, we have a saying that wood is a combustible or burnable material. Yeah. 2 minutes left, I'm told. Okay. Meaning that if a fire occurs in the building, it will collapse. We have steel and concrete on the other side, and they are non-combustible materials, meaning that if a fire occurs in the building, they will theoretically not collapse. This is not the truth, of course, because steel, when it gets heated up and so on, it will start collapse. But it's just a minor thing in the building codex, making it extremely difficult to use wood as a building material, especially in tall buildings. So the bubble question, now I'm almost there. The question I get asked the most here in Denmark is, aren't you afraid that it will all fall to the ground? Now the market is unstable. We have a war going on. We have a Russia situation and so on and so forth. But my answer to this question is nope, not at all. If we see this bubble as the present day building mass in the Scandinavian market in general, this is what the wood building sector is in size. So even if the bubble turns smaller, we still have a lot of space to grow when it comes to constructions. So now, why are we talking about wood? I personally believe that it's because wood is a fantastic material that we are just getting started to rediscover. Goes for bio-based products in general. And we have a saying here that it's grown products instead of ground products. What is your thought on this? This is what I started the presentation about, that you should think about. I really would like to know, and if you could leave your take on it in the chat function or any other way, you could put comments on my LinkedIn profile and so on. I would highly appreciate it. This was my short introduction. Thank you, everybody, and have a great presentation.
Wow, thank you, Kenny. Thank you for sharing with us your experience with mass timber. I would say the Nordic experience in using mass timber. They convert to convert from square meters to square feet. You can multiply by 10, and you can get the right number. So I learned during my trip between Europe and US. So thank you again, Kenny. I hope you can stay with us until the end of the conference, because we will have a round table. We will collect all your questions, and I hope to start a very good conversation, very good discussions with the other speakers. Now we move from Denmark to Kenya to Africa, and the next speaker is Leander Mons. we met with Leander a couple of times, and the last time was in Portland because we were both attending the Mass Timber Conference. What impressed me is that Leander and some colleagues were presenting what they are doing in Africa to promote the use of timber, of mass timber, and I was really impressed because it's my fault, but I was not aware of what is happening in that continent. So please, Leander, the stage is yours. Share, tell us what is your experience.
Thank you, Franco, and welcome everybody. I will not tell too much about myself. I'm Leander Moons. I'm an architect. I founded OMT Architects a while ago, and we started to work in Africa with timber. And that basically kicked off in 2015 when I was invited by a developer of what it was supposed to become a city here to 2 houses he had built, and he had difficulties finding an architect for that development. And that development was, of course, a lot about like creating a new community, creating like a green community with a lot of permaculture, with waste recycling, all these things which we all aware of and which are great when you start a new city. But he wanted to go like a step further than that, and that's where we came into play. He wanted to go from best practice to innovation, and he was wondering how to do that and basically said, okay, I have to give people choice. So you see the same image here on the screen, and one of these buildings or some of these buildings are best practice and the other are innovative. So some of those represent a value and others are a relatively big risk. And that basically is down to the way they were constructed. At that time, with engineering only, they said, let's like just give people an option to buy either a stone house or a timber house. And nobody knew if that would work, and nobody knew if it was possible, and nobody knew if it was possible in Africa in this context on an island. Nowadays, we've seen that like 50% has been built in timber, and we see a lot of benefit in that. Of course, with the timber construction, we not only tackled the better production methods by taking this offsite, therefore reducing waste on site, but we also helped to increase or improve construction safety. On the left you see, and this is really 100 meters apart. On the left you see a conventional construction where they take the castwork away by hand, and on the right is our pop-up factory where we off-site produce these timber elements, and we're in a tropical context, so we have like a shaded space, a weather covered space where the wall elements are produced to go on site. So in the end, I think a lot about like this, like how do we start with timber is about making the safe bet. And this is a funny picture for those of us who are in the US. The Ford F-50 is for years already the most sold car in the US, but Ford is not making big profits. And to the right, you have the Tesla, we all know, which we consider the future. Now, can we do something similar in building industry, and how would that look like? And why would we do that in Africa? So for us, it's clear when we look at the demographics in Africa, with rapid demographic growth over the next 23 years, and I summarized here a couple of key criteria there, we will see a population increase by 1.2 billion people on the African continent. Now, if you consider that an average household size in Africa is around 5 people, that means that in the next 23 years, we need to build 240 million houses to allocate only those people. And we still have a huge backlog to also fulfill. So Africa, other than the rest of the world, has a huge demand for housing. And what happens to our planet when we do all of that conventional? I don't want to think about that. So we have to think about there where the demand is, how we like change a construction business. And then a lot of people, of course, think like Africa, you know, that is a lot of desert. That's right. In the northern part of Africa, we don't have many trees. But actually, if you look at the amount of trees in Africa, you will see that there is a bigger forest coverage in Africa than in Asia. Now, a lot of people will say that is all primary forest, we should not touch it. And also there is of course, primary forest, but for example, in the southern part of Tanzania, where we have a forest coverage of 52% in the country, we have like huge plantation woods, and they are elevated, so it's pine and eucalyptus trees mainly, for which the pine would be perfect also for construction. It's currently not used for that, so how can we change that? And we do see that, of course, in the traditional way of constructing, and also nowadays in construction, these are images from the traditional historical town of Stone Town as part of Zanzibar city. We used a lot of wood. We used wood on the interior, we used wood for balconies, for doors, and we used wood for construction. So wood is there, but we just don't use it as a structural item in construction anymore. So if we want to reintroduce that, we need to look at the whole value chain, especially in a context where this is not done to that extent, and where there's no timber industry at the moment in relation to, for example, what we know in Europe or in North America. So when we do that, and I'm an architect, so I have to tell also a bit about the architecture, we of course look into the historical context. And again, these are images from the historical town of Stone Town, where you see like a lot of these buildings having timber elements and are very like also vocal about like these timber elements. And these are over 100 years old. It still functions even in the traditional and in this tropical climate by using like the right design approach. So when we start to reinvent projects, and I will talk a bit about this project we're doing because this is equitable housing really focused on the local market, we look at those traditional means and try to like reinterpret those into a modern context. So for this building, we have two sides of the building. One side is residential, the other side is more commercial, because we think then that not only we need to look at like these buildings as part of like an engineering effort, we need to think about these buildings as part of a community, and this community needs to be diverse. So we cannot build a single building for one kind of like communities. We need to incorporate different people, different generations, and we need to mix living and working conditions. So we created a building which can allocate everything from workshops to studios to apartments. We have like 64 different typologies which we can integrate in one building. And then of course, it comes down to the fact like, how can we now make this building effective? These studios are sold for 10,000 USD for a studio. So we have to be cost effective, and we want to build this with timber. Of course, we also want to show a bit of that timber inside. So you know, it's a big challenge. How do we bring that together? And of course, the way we bring that together is down to looking at how can we optimize the building, and how can we optimize like the elements we use for constructing this building. And that of course starts, especially when we talk timber, with fire. So we need to overlay our fire life safety approach. And Kenny also mentioned it, like we rather want to save the people than to save the building. But we need to overlay that approach also with our structural items, because if we do that, we can be very effective. And then on top of that, of course, we can use a modular approach. For example, here in brackets, you see the bathrooms, which are all the same hardware. We even use that for other projects, no matter if that's a 10,000 USD studio or a $500,000 USD villa. It still has the same hardware. We just changed the tiles and the fixtures. So that is a simple approach we can use there to optimize the building. And then we have like the great opportunity in Africa, where we're developing a whole city, to also look into how can we then optimize our buildings? How can we go from the first initial intentions to a more optimized approach? We as architects really believe that we should minimize our resource use and that we use as much local material as possible. And I just called out here one single thing we looked into. So for the first generation of these buildings, we used like a composite floor with notches into that floor with smaller elements. And when we seen that coming to site, and also in the manufacturing process, we seen that it's all single items. So we were thinking about how can we simplify that, and we went from that singular approach with composite floors to a slightly less cost-effective floor build-up where we have like only a CLT panel, but now all of a sudden that CLT panel can be 3 times the size. It can exactly fit in the container, and it's much simpler to install. So that's what we have on investment cost as an add-on. We save on the construction side by simplifying its implementation. And now I'm waiting for the next slide to come. There it is. So from there, we then moved, and this is again on the left, you will see the first iteration, so the first generation of this project, and on the right, you see the second iteration of this project. And this is like the connection between a conventional build core, because of fire reasons, still conventional, also for the permitting authorities, a lot easier to deal with than with timber, where they don't know much about. And then you see like some details in Europe or in North America we would not apply, but we do apply in the local context, because we have a large discrepancy in tolerances between conventional structure and local structure. And also on the left, we use South African produced CLT, which burns a lot faster than European produced CLT. And therefore we had to take additional precautions in terms of like how we created the support for that ceiling. So all of that like led to a detail on the left, which was quite complicated. And when we now came to the second generation of that project, we simplified that by actually stepping away from CLT for parts and going back to prefabricated stick-built elements. A bit wider, double wall, but more effective, more simple, and also more cost-effective. So we actually managed to reduce the building costs as well. And I think the detail shows how much easier it is. And something we gained by doing that as well is going from the composite floor to the general floor, is that we don't have the complicated detail where we have to tie in the rebar of the composite floor into those conventional built cores. So a lot of that is really design and redesigning it after the experience on site. And I think that is very important in this approach, and especially if we want to implement this in Africa. So this is currently the construction site. The timber all has been produced. We hope to assemble the first building towards the end of the summer. And then we already have like 8 more buildings which are coming up, and eventually that should be around 30 buildings. And of course, this experience which I shared about this building is based on the other projects we do. We do a lot of like different size buildings. So we started with single story, we went to 2-story approach. This is a 3-story full CLT that we will never do again, because it's just way too cost or not cost effective enough in the context. Of course, it looks great also from the inside, but also here we followed the approach. How can we go from CLT to more local material, and also to become more cost effective. So on the left you see the CLT in orange, on the right you see the CLT left. It really is down to there where we also expose the CLT, where we can use it for the stiffness of the building and where we see it in our stairs within the units. And this was one of the first projects which really kicked off this development. We're there now building the 20th building. And this is a very simple approach where you can choose basically between an apartment, a room apartment, 1 bedroom or 3 bedroom, all based on a modular approach, all prefabricated on site. By a pop-up factory, and then just assembled just right next to it. Very straightforward, like a building stands within more or less a week. The only thing is that we then, after we actually assemble the concrete, built like the staircase in conventional method into the building. So the other way around than what you normally would expect. So here you see it's very simple stick build, and here we still use the composite floors, and then that's the interior from the finished building. And we do a lot with timber, of course, looking into that, but of course at the same time we also look into passive design measures, which are so important when we design buildings, and we should not forget about, like cross ventilation, permanent sun shading, which enhances then the interior material climate, and also helps like the timber, because a good ventilation, of course, is key for timber in an interior exposed situation. And at the beginning, you've seen the town with only 2 houses. So this was the town actually half a year ago. It's incredible how fast it grows on the foreground now. That has been much further developed already. So we are providing quite a lot of houses. Still, it's nowhere near this 240 million houses we need. For example, in Tanzania, that would mean that we need to build more or less 1 million houses a year. Well, we are maybe providing 1,000, so we need to do that in 1,000-fold. Going forward. So it's a huge, enormous task. We are trying to contribute a bit to that, and there's unfortunately still very little people who are working in Africa, but I think it's in our best interest to look into Africa, because here is such a big demand because of the demographic development. And of course that also includes not only low-rise, we are also working on a high-rise building, which will be a landmark project for this development, starting construction next year, and yeah, looking also beyond that to further develop like this approach throughout the continent. So that is my short presentation of what we're like trying to contribute here, and of course I'm very happy to hear any questions and have a great discussion also with the other members of this conference at the end of all presentations. Thank you.
Okay. Well, there was a bit of a problem between one speaker and the other, so sorry for these few seconds. So thank you very much, Leander, and I really want to keep going this conversation with you at the end of the conference for the roundtable. We already have a lot of questions, and some of them will appear on your screen during the next presentations. We have, I don't know how many countries, how many people from different countries we have here. We have Africa, Australia. There is my friend Alan from Brazil. Thank you, Alan, for joining. Welcome. And now it is time to move to the next speaker. His name is Craig Applegarth. He is the founding partner of Dialogue office in Toronto. We met a few times, and we have two things in common: a passion for mass timber and for Monty Python movies. But this is a long story. We met a few times with him, and he is a great architect and very passionate about how to decarbonize the building sector, and it is something we really need. I know he has a lot of things to say, so please, Craig, now is your turn. Thank you for joining.
Thank you very much, Franco. And you see my slides coming up there? There we go. So today I'd like to talk about the zero carbon hybrid wood super tall future that we might envision using a hybridized form of mass timber, and why it's important. So about 6 weeks ago now, the latest IPCC assessment report number 6 came out, talking about where we stood in terms of emissions of carbon dioxide and their potential impact. And it wasn't good news. Between 2010 and 2019, they were not moving down, they were moving up. In fact, 12% greater in that time. And I think Greta Thunberg sums it up with this: our house is on fire. So what can we do as an industry? I think one of the clearest things that we can do is build with wood and build with mass timber. This is a project that I'm currently working on right now. It's a community college. And just to give you a sense of how powerful using wood is as a climate tool is, it has 15 to 25% lower embodied carbon, lower embodied CO2. And 1 cubic meter of wood, as you probably know, stores 1 ton of carbon dioxide. So mass timber buildings, wood buildings, are storage vehicles for carbon. So what have we been doing as a practice, dialogue as a practice over the past decade, to just give you a context of the project I'm going to show you? About 14 years ago, we started with this small forest research center, 1-story mass timber. About the same time, we designed the UBC Student Center, a hybrid mass timber, steel and concrete. This is more recent. It's on the boards right now, 2150 Keith. It's a commercial office facility, mass timber structure. And this right now, which is just finishing construction, it was I showed you the under construction view of it, and it's now like this week it's finished. It's a 6-story college facility, all mass timber. And this is a project that we just won and are starting to design. It's for the Seneca Polytechnic Health and Wellness Center, 100,000 square feet of recreation, fitness, well-being program. So I think you might have noticed something missing from all these examples. Tall buildings. So how can we integrate mass timber into tall buildings? Hybrid wood towers. In 2018, a number of our partners at a dialogue annual general meeting got together and said, what are we going to do? How can we make this happen? So we said, let's do a big, hairy, audacious goal of designing a 100+ story hybrid wood mixed use zero carbon high-rise prototype. And we said, how can we design a mixed use high-rise building using wood, steel, concrete, and other advanced materials that maximizes the overall use of sustainably harvested wood by volume in high-rise construction in the most cost-efficient, energy-efficient, low-carbon, and elegant manner. That's also conducive to human well-being and well-being of the environment. That was our starting point. And so this is the most important thing that we discovered as we started to do our research, was that in high-rise buildings, 60% of the building materials are stored or are used in the floor systems. So we said, well, let's look at designing a hybrid wood structural strategy that sees the key impact being how we use CLT in the floor system. The exterior system will be concrete core and then steel diagrid exoskeleton. So very, very typical of a tall building, steel exoskeleton, concrete core. But in this case, the magic will be a CLT floor system. And this gives you a sense of how that works. You can see these 10-foot by 40-foot floor panels arrayed around the core out to the steel exoskeleton there. And these panels are set up so that they are also a hybrid of CLT plus a post-tension steel tendon, 2 post-tension steel tendons in each 10 by 40 panel. And so you start to do this, you start with a 10 by 40 foot steel panel. And by the way, why this is important and very, very innovative is typically mass timber, CLT, spans about 25 to 30 feet at most. So you have to have an intervening beam and column if you want to have a typical office floor plate, which is around 40 feet from the core to the exterior wall. So we said, how do we make a CLT floor panel that allows us to have that 40-foot length? And so this is how we came up with it. And the 10-foot is the dimension required to put on a truck. And also, these things have to be lifted up into place by a crane. So you basically CNC a trench profile for the panel. You then put in the post-tension conduit as well as the rebar around that to connect it to the CLT panel. And then you put a steel reinforcing grid on the top of it for the concrete that will go on the floor above for acoustic purposes, as well as for setting in electrical conduit. And this gives you a sense of what it's going to look like. So you have all the mechanical systems going on at the core, and then you see the ceilings are clean, and they have no intervening wood beams and columns. And this gives you a sense of the value proposition. Here's a typical CLT timber grid, 20 to 30 feet, and here is the hybrid floor panel grid of 40 feet. So structural testing. This is not just an idea. We teamed up with FP Innovations and LS Dawn as partners in order to test the panels to see that all of our calculations, our theoretical calculations, our engineering calculations were borne out in reality. So this is LS Dawn's plant out in Thamesville, and they are now building various, or have been building various component parts to be tested by FP Innovations. This gives you a view of one of the pieces of the rebar inside the concrete reinforcing there. And this is what it looks like after it's been tested in the burn chamber. So it meets all of the requirements, and it proved to work. This now is them pouring the concrete around the post-tension conduit and for the whole panel itself. So there it is poured. And then this thing weighs the same as 15 F-150 trucks. Turning it over, there it is. So these are, we built 2 of these. And to end off by saying some people want it to happen, some people wish it would happen, others make it happen. And that's our job. Thanks.
Okay, Giorgio. Okay. Well, thank you very much. Thank you very much, Craig, for the presentation. I'm always very impressed by that skyscraper made of timber. We can talk later, but skyscrapers, tall timber buildings could be kind of a hot topic for the future. Yeah.
I think so, Franco. And the key thing I think is it's one thing to use all mass timber in a building up to say 12 to 20 stories, but there are cities around the world where the buildings are somewhere in the order of 60 to 100 stories. So if we want to use wood in those buildings, we have to have a strategy, and that's what we're aiming for.
Yeah. And I agree with this. We always need to push the boundaries. I like to do it, and I like to see people and companies doing this as well. It's really impressive what you've done. Okay, so we can talk later. Please feel free to add your comments, to add your questions on LinkedIn. We already have collected many of them on Zoom and LinkedIn, but I would prefer you to use LinkedIn only. The next speaker is Ricky McLean. We met a few times with him as well. He leads the Woodworks Growth and Innovation Program. He is very active on LinkedIn. You can find many short movies talking about mass timber, talking about the use of mass timber and how we can improve the use of that mass timber, how we can promote the use of mass timber. Woodworks is doing a great job in promoting the use of mass timber, in letting people know how to use it, how to design it for architects, how both architects and engineers should use mass timber for their buildings. So, Ricky, now it is you. We stay in the US for this speaker. So please, Ricky, it's your turn.
Thank you. Great. Thank you, Franco. Really inspiring several presentations that we just saw there. And I'm going to take us on a bit of a journey through something that's, I think, tied very closely to the theme of the conference, but also tied closely to what Franco mentioned that we're working on at Woodworks, which is helping enable folks to design their own mass timber buildings and providing them with the education to do so and knowledge to do so. And specifically, what I wanted to cover today is some of the cost aspects of using mass timber. We've seen mass timber used in a variety of applications in the presentations prior, but I think one of the common themes throughout all of them is, of course, it has to make sense from a cost perspective. So that's what I'm going to talk about in my presentation. Is here are some of the ways to think about the cost aspect of mass timber and how to design to really maximize and optimize the timber elements so that there's a higher level of success and chance of using it in the first place. Just real briefly, as Franco mentioned, I am with a national nonprofit organization based here in the US called Woodworks. And our goal is to be a free resource to the building design, development, and construction community. So we are a free technical assistance program for those who are in the US or working on projects in the US. Please feel free to reach out. We offer all of our services for free through one-on-one project specific support and education as well. So encourage everyone to reach out. There's a local regional director close by to wherever you are. This is just a quick map showing really the progression of mass timber construction here in the US over the past about 15 years. And you can see really a significant increase in the number of projects. This is showing the number of projects and where they're located, really since about 2016, 2017. So really the use of mass timber has grown significantly in that amount of time. And we're at now about 1,750 mass timber projects in the US, either completed or under construction or currently in design. And one of the aspects that I work on here at Woodworks in particular is taller projects. So very, very much tied to what Craig was just covering in terms of supporting the use of mass timber in tall projects. So just over the past couple of years, we've seen that number grow from just one tall mass timber project here in the US to now having the world's tallest mass timber building in Milwaukee, the Ascent Tower, sitting at 25 stories. And there are a number of other tall projects going on now. And I think one of the things that's really exciting and encouraging about that is specifically seeing the use of mass timber in housing, in multifamily housing. Leander showed a lot of exciting things that are happening in Africa with the use of mass timber in housing. And we're seeing similar, especially I would say on the affordable housing side of things, which is really good to see. So that's an example of a project there that you just saw at 8 stories of mass timber. And then this is a project currently under construction in Oakland, California, which when it's done will be 18 stories total, again, providing multifamily housing. I don't have time today to go through the nuances of all of these types of projects, but suffice it to say that the structural systems on all of these are actually quite different. And that's what we'll cover really in the next 10 or 15 minutes here is how to understand what could be the best structural system for your project and what are the cost implications of designing it one way versus another. This talk is going to be definitely focused more on US building practices and codes, but I do think a lot of it translates across the globe. So in the US, we have all of our projects designs are essentially based on the International Building Code, which is a code that's updated every 3 years. And I think kind of stepping back, I have a structural engineering background, and thinking about how we would normally go about designing a building structurally. Let's say it wasn't mass timber, it was some other building material. Oftentimes it would be the architect would generate a set of preliminary floor plans. And then as the structural engineers, we would basically have to figure out, well, what walls can we hide columns in, for example, and how can we kind of lay out a structural grid that may not be perfect grid, but it's basically allowing the architect to create the interior spaces that the owner needs, while we tend to try to hide as much of the structure as possible. Of course, we know with mass timber, it's really the opposite, right? We want to expose the structure, but because we're doing that, we also want to design the structure in a way that's more efficient. So when thinking about kind of that progression, like what's the first step, what's the second step, what I would suggest, and this is just a possible design route, and I'm not saying you have to do it this way, but I do think there's some efficiency in this, is to start out by understanding what the owner needs from a building size and layout perspective, From there, choose the construction type that is basically on the lowest end of the spectrum that still works for the building size. So lowest end, I mean, if you're familiar with the construction types in IBC, starting at 5B and then going to 5A, then to 3B or to 4HT, 3B, 3A, and so on. So first dialing in that construction type, because that's going to dictate the required fire ratings. We've heard several times throughout the presentations today the importance of fire design of mass timber, and it's particularly important because of the fact that you're exposing those timber elements. They're having to achieve a fire resistance endurance, and they're also the structural members of the building. So once you know that fire resistance rating, that starts to dictate what would be the most efficient size of the timber members. Then once you know the size of those timber members, then you start to look at, okay, what would be the most efficient grid layout or spans? So it's really almost turning a lot of that thought process on its head, meaning first you lay out the floor plan, then you figure out where can we put columns. It's based on the size of the building, what are the fire ratings? Based on those fire ratings, what is the most efficient timber sizes? Based on those most efficient timber sizes, what is the most efficient timber grid that works within those parameters? And again, the whole point of this is to dial in to optimize the fiber count, the connections, the piece count, all of the things that we'll talk about in terms of what are some actual metrics we can use to gauge these things. Of course, acoustics, MEP integration, lateral system selection, working within the capabilities of a given manufacturer are all very important in this context as well. So this is a chart, if you're familiar with the International Building Code, that kind of lays out, what is the construction type options that you're looking at based on the size of the building that you're working on. And I would say too, with mass timber, it's, don't assume that there's going to be a single best option. There's usually multiple options, unless you're, a tall building in excess of 7 or 8 stories. But if you're in the 1 to 6 story range, there's usually several options for construction type. So I would strongly encourage you to assess all of those options and see which one works best. That's also something that we do a lot of in terms of our assistance at Woodworks. So again, construction type, then once that's chosen, that dictates what the fire resistance ratings are. Those fire resistance ratings then have an impact, as I mentioned, on what is the most efficient size of the members. Because if you're looking at, for example, a 1 hour fire resistance rating, and we're designing, say, CLT floor assemblies, it's usually difficult to get a 1 hour fire resistance rating on something that's, say, a 3-ply CLT member because of its relative thin depth. So if that's the case, then that might then push you to look at, say, a 5-ply CLT member. So if you already know you're going to be based on a 5-ply CLT member, then you can start to see, based on the structural properties of that 5-ply, the vibration characteristics, you're probably going to be looking at floor spans in the range of, say, 14 to 17 feet. And I apologize, I didn't do the conversion to metric units here. But, so if that's the case, then, you can start out prior to laying out the grid. You already kind of know you want to be in that range of 14 to 17 feet, if at all possible, to maximize the spans of the timber elements based on having to meet a 1 hour fire resistance ratings. So there you go. So some examples of how you would actually implement that on a project, because that's not to say that, like we said, a 15 to 17 or 14 to 17 foot span, that doesn't mean that the columns have to be 14 to 17 feet apart. It just means we have to have beams at those dimensions. So one example, this is a project, it's an office building in Denver, and the client here wanted a 30 foot by 30 foot grid to meet the interior space layouts. They were able to use a type 3B construction, which has a 0 hour fire resistance rating. 0 hour fire resistance rating, then you want to use the thinnest panel possible to minimize the fiber count. And so they were using a 3-ply CLT. 3-ply CLT is most efficient for floors spanning 10 to 12 feet. So knowing that they're using 3-ply, its efficient span is 10 to 12 feet, but the client wants a grid of 30 feet by 30 feet. Then what this design team came up with was the framing configuration that you see here, which is beams at 10 feet on center, supported on girders that span the full 30-foot dimension. And so those purlins, or those intermediate beams, also span 30 feet in the direction. But again, minimizing that CLT to a 3-ply for fiber count optimization. And then if you are doing a project like this one here, which is now a type 3A construction, which has a 1 hour fire resistance rating requirement, again, 1 hour, probably start looking at a 5-ply system in this case, which is about 7 inches thick. A 5-ply system then is, like we said earlier, efficient spans in the range of 14 to 17 feet. So then you might look at, a grid. If again you're going back to that 30 by 30 grid, you might then just have beams at 15 feet on center. So one intermediate beam. You still achieve the same grid, the same column dimensions, but you're reducing the number of intermediate beams or purlins, which of course has an impact on the piece count as well. So as I've mentioned there a couple times, I think it's important to really dial in that thickness of the panel and optimize that based on the required fire resistance ratings. And the reason that I think that's so important is because of the fact that the panels are the biggest piece of the biggest part of the mass timber cost package. If I go back here for a second, you can see this is a chart. Whoops, something's going on with the slides here. That's okay. Essentially a chart showing, where does most of the cost, the majority of the cost of a mass timber cost come into play, and that is tied to the materials themselves. And the panels usually make up about 70% of the volume of fiber in a mass timber project. So starting out by minimizing those panels to get the most efficient system is where I would start. And just some examples of what that looks like. This is an example. Say we have a 30-foot by 25-foot grid. It's a type 3A, so it's a 1 hour fire resistance rating. So you can see we have one intermediate beam to get the span of a 5-ply to 15 feet on center. One of the metrics that I've seen used, I think works quite well to gauge the efficiency of a given mass timber design is looking at the volume of timber on a per square foot basis. So if you add up the total volume of, in this case, a 5-ply CLT, those beams that you see at 15 feet on center and the girders, you get a total volume here divided by the 30 by 25 area of 0.73 cubic feet per square foot of building. And again, you can do the conversions for metric units. Now, if we look at that same grid, but let's say we are now construction type 4HT, the option now is to go with a 0 hour fire resistance rating. And so what we're going to do is let's pull down that CLT to a 3-ply instead of a 5-ply. So we've reduced the CLT thickness. We've added an extra beam now. So now we have 2 intermediate beams, but you can see the net result is a pretty significant reduction in total timber fiber. So now we've gone from 0.73 on the previous example to 0.51 here. So it's something to think about where, minimize the fiber count, but increase the piece count. You kind of have to play that balancing game of what is most efficient for your project. But I think these examples provide you some ways to kind of assess that. We do have a resource on the Woodworks website related to vibration. And then in terms of fire resistance, design of mass timber, I think this is fairly common in the US as well as in other locations throughout the country. Testing is one of the most common ways of demonstrating that the CLT or the glue lam that you're using has been validated through testing. And we've combined all of the known, I think the slides are just kind of skipping ahead on their own. That's okay. All of the known fire tested assemblies. We're aware of over 50 of those currently that we've combined into an online database of mass timber fire tested assemblies. And then there's also a calculation-based method where this is based in the NDS, the National Design Specification, which allows you to calculate up to a 2-hour fire resistance rating using a nominal char rate of 1.5 inches thickness of wood per hour of fire exposure. And that essentially is just doing 2 checks, one structural check pre-fire, so the full thickness of the timber member, and then you reduce that timber member based on the fire endurance that's required and the thickness of the char that develops there. That leaves you with a thinner member of timber, and you're checking that in the post-fire condition, but you are allowed to increase the properties on that member as well. And I think just the last thing to quickly cover is that it is important to think about, you saw Craig discuss the importance in his project of really minimizing the intrusion that MEP has on the system and the layout and the aesthetics. There's a number of ways to accomplish this in mass timber buildings. running fully below the mass timber, running through the timber elements like you see here. But of course, this does have an impact, not just structurally on those beams, but also from a fire perspective, right? If those were 1 or 2 hour rated beams, like you see here, if you have to account for the fire exposure within those beams, as well as with the total size of the beams themselves, I can see the impacts of a 1 or especially a 2 hour fire endurance on the size of those beams is quite significant. So there's a number of reasons why thinking through the MEP layout and integration in a mass timber building early on is important. This is kind of showing you some of those ways and examples that we've seen MEP integrated creatively in a number of mass timber buildings through gapped panels, through raised access floor systems like you see here. And then on connections, there's some common proprietary systems where you're fully concealing the steel hardware of a hanger. There's custom fabricated options, and then there's something like wood bearing. So there's nuances and differences with all of those in terms of the cost of the connection, the aesthetics of the connection, and the structural capacity and fire capacity of those connections. And we've consolidated some of those into an online index of mass timber connections on the Woodworks website. So just in closing, to leave you with some of the metrics that we talked through of ways that I think it's helpful to kind of assess several options on a mass timber building. It's again that the volume of timber on a per square foot basis. Maybe run 2 or 3 scenarios and see which one gives you the lowest volume per square foot. Penetrations, we talked about the impact that penetrations like through beams have, or even through panels from a fire perspective. But of course, that's also something that has to be coordinated and fabricated by the manufacturer. So maybe again, look at several options and understand how many penetrations does this option give you on a per 1,000 square foot basis. And then the last thing is pick points. How many actual picks of a crane does one system require versus another? Because like we saw, there may be a trade-off, less volume of timber, but more pick points. So it's just assessing those options, not saying that one is the best, but this allows you to have some metrics to actually track, what those things are and how they compare from one building to another, or even several options within a given building. So there's a number of resources on the Woodworks website, as well as the Woodworks Innovation Network. But I thank you for your time today and look forward to the Q&A at the end.
Okay, well, thank you very much, Ricky. A lot of interesting things to talk about during the roundtable, during the final roundtable. The cost was very interesting. The slide you showed about the cost, about the impact of the cost of the mass timber of the panels on the total cost of the structure. It is a question that raises many times when it comes to mass timber. How much does it cost? We will try to deepen a bit more, to dig a bit more about this topic. Now, I'm very happy to welcome the last speaker of today. Here is Jerry McCoggy. He is also very well known as Mr. Offsite, because he is the one promoting the use of offsite technologies. And we met in San Francisco last year at a conference. So it was very inspiring. His presentation was very inspiring. And today he will speak about Offsite as the CEO of the company Offsite Tech, based in California. He has international experience. He has an international experience in producing and realizing stick frame buildings. So I'm very curious to listen to your presentation. Jerry, please, the word is yours.
Thank you very much, Franco. And as many of you will guess, although I'm down as an American, I'm Irish originally, so I'm a long way from home in California. And as Franco said, a lot of my presentation sort of relates to an experience that goes back over 30 years in my case, that spans the United States to Europe to as far away as Japan. So I'm delighted to be here, and although I want to say is this presentation I normally do takes about an hour. I'm trying to get this down to 15 minutes, so I hope that it works in that context. And the second warning in this is, I'm not really a mass timber guy. I'm an off-site prefabrication person, but I think many of the lessons from off-site prefabrication that I'm involved in also equally apply to mass timber. And in particular, I think there's something interesting here, which is the area relevant to cost and how cost is addressed when talking to the client. So hopefully there'll be some interesting insights in one of the case studies that I'm going to do towards the end of this presentation. So let's see, is my presentation coming up? Oh, there we go. So my presentation is, if it's not a system, it's not a solution, which sort of goes back to the whole idea of DfMA. You have to design it for manufacture and assembly. That's where that's the secret to offsite construction, and it is also the secret to where you actually are able to prove that maybe the first costs, which look higher, actually overall of the total project, that's not the case, that you actually save money when you use it as a total system. So a little bit of my history. I was a co-founder and CEO of a company in Ireland called Century Homes, which we sold to Kingspan, many of you who may know, back in 2005. But when we started that company in Ireland in the 1990s, just to put this in context of, again, where mass timber can go in a short period of time, in the 1990s, less than 2% of all the houses being built in Ireland were wood frame. 98% of them were being built out of concrete. That's low rise, mid rise, high rise. It was concrete dominated. But then what happened back in the 90s was there was with the Kyoto Protocol and increased interest in lowering the CO2 emissions from each of the European countries, there was an increased interest in energy efficiency standards. There was also a labour shortage, both skilled and unskilled. And in the case of Ireland at that particular point in time, there was demographic factors that actually were causing an increased demand. So there was a requirement for more homes to be built. So that actually led to, I suppose, it was the initiation of looking for different methodologies to build homes. And obviously wood, because of the speed, and two, because of the environmental benefits it has, sort of became an interesting topic, although the regulations at that point in time in Ireland were very much, I don't want to say anti-wood frame, they were just never written with it in mind, which effectively meant that it was very, very difficult to build anything over 2 stories in wood frame. Sorry, it's lost the connection here. Okay, but to put that in context, by 2015 or 2005, when we sold Century Homes to Kingspan, at that point in time, actually, Ireland had gone to 30%, from 2% had gone to 30% use of off-site wood frame constructed homes, because in Ireland and the UK, and you can see here from Scotland as well, Scotland penetration is 84% wood frame, but in the UK and in Ireland, when you talk about wood frame, you always mean panelized or off-site construction. In those markets, there's no such thing as stick framing. It's all being done in a factory-controlled environment and then brought out to the site, which means it's all going through design before it ever hits the job site, so all the problems are worked out in advance. Sorry, this is getting slow. So as I said, my career has been dedicated to offsite construction, and although in many ways offsite is seen by many people as being something that's relatively new, meaning that it's been around for just literally the last 10, 15, 20 years, my family has actually been involved in offsite construction for 60 years. My dad actually went to the United States in the late 1950s, discovered wood framing as a methodology for building homes, came back to Ireland and set up the first wood framing business in Ireland at that point in time, which went on to become the largest in the UK and Ireland at the time. And then subsequently, we set up Century Homes, which actually went on to become the largest unit producer of low-rise wood frame buildings on the European continent. So it's been around. So you could say effectively it's in my DNA. I've been doing nothing else all my career other than wood framing. I apologize for the delay in this, but one of the things that I want to address with this, and again, I think this applies somewhat to mass timber as well. You have in the wood framing industry, I suppose, the distinction between those companies that are whole solution providers and those companies that are component providers. The component providers meaning they'll supply one piece of the element to the builder, and then the general contractor or the developer or whoever's involved in the project has to go off and source all of the other elements to do with that particular part of it. And particularly here I'm talking about the structural framework, and that's the same regardless of whether it's a mass timber or whether it's light wood framing. But as Aristotle quite famously said some 3,000 years ago, the whole is greater than the sum of the parts. And I think that's key to, again, this thing about costs. If you bit piece it and you're getting separate items from different suppliers, you still run into the problem of uncontrolled costs and finger pointing going on, and nobody quite sure who's responsible for what, which all that does at the end of the day is actually add to the costs in getting the project completed. So what I like to say is, if it's not a system, it's not a solution. And I think, again, that applies equally well to mass timber as much as it does to light wood framing. If it's not a system, it's not a solution. It's the system that provides the benefit. Because in reality, what the customer is buying, they're not buying the components, they're not buying the mass timber, they're not buying the light wood frame. They're buying a solution to help them get that building built as quickly, as efficiently, as environmentally friendly as possible. Obviously to a budget, but they're looking for the building to be complete. They're not buying the individual components. Therefore, they're looking for the system. So it is key that when we go out to market these products, that we're going to the customers with the system. And again, that's where you will find that you can actually reduce the costs, or at least it's where you can have a legitimate discussion with the customer about what the true costs are of that particular project. So you think about it. If you left here now, and I wish I could see all your faces, I normally ask this question. If you left here now this evening, wherever, depending what part of the world you're in, and you go out to buy a car, and you went to the local dealer and you were going to buy a BMW or a Mercedes or a Toyota or any car, and you said to the local dealer, I'd like to buy a new car, and the dealer said to you, well, I'll give you two options. Option one is, I'll have all the components shipped from the factory to your front yard, and I'll have 5 guys come out in a pickup truck in their Ford F-150 with some pneumatic tools and welding gear and put the car together in your front yard. Or I can have the car built in BMW or Mercedes or Toyota's factory. Which one will you take? The logic says, and that applies equally well whether it's your iPhone or whether it's your computer or any other product that you use. You would always prefer to have that particular product built under factory controlled conditions and brought to you in this nice, shiny, wrapped up box, and you can take it out and use it. Because at the end of the day, if you tried, although that car could be shipped to you, and every single one of those parts could be shipped to you for that car for it to be built in your front yard, there's no way you would end up with that car being built to the same cost effectiveness or to the same quality as if it was built in the manufacturing plant of that particular manufacturer. But why don't we think about housing in the same way, or buildings in the same way? It's something that's, they say what I like to say is that the 7 most dangerous words in the English language are, that's the way we've always done it. And I think that's something that you hear more so in the construction industry than you hear in any other industry. That's just the way we've always done it. Well, it's, I think, time to change that. And what I'm talking about here, again, go back to particularly the systems that I'm talking about is there's various different offsite methodologies: component, panelized, prefab, modular, precast, volumetric. So the area that I really focused on is component, panelized, or prefab. You could put it all into that. And what I've typically over the years come to call that is a fully integrated offsite solution, which includes the process, business plan, the manufacturing. You have to have the total system. What's again key to this, especially when you come back to design, and I emphasize design for manufacture and assembly. My experience is that 80% of the benefits of offsite construction are achieved before a piece of lumber is cut or processed or a nail gun is ever fired. Because in reality, offsite construction is about process improvement. It's not about the components. But everybody focuses on the components because of the physical hard product that everybody sees. What you don't see, the work that's going on in advance, from the digital twin that's being produced to work out all the problems before you ever get to the site, to the planning with all the stakeholders before you ever go there, to working out the problems. That process improvement, that discipline is actually what brings the benefit. And again, goes back to that is what actually lowers the cost on the project. It's not the component itself, although obviously they're a key element of it, but it's that process improvement. That's where the cost savings are. So when you just simply compare material against material, it's very hard to make, whether it's mass timber or even light wood frame panelized, it's very hard to make it stack up because we're not arguing the right point. You need to discuss about the process improvement and the benefits that that brings to the total project. So it's the total cost. There's a guy in the United States would say, Scott C. Dam, he said, if you don't know what your total cost is, or sorry, if you only know what the first cost is, you'll never know what the total cost of the project is. And it's the total cost that matters. So what is a fully integrated solution? Well, it encompasses all of the following: design engineering, offsite manufacturing, the delivery to the site, the on-site assembly, and the finishing. And I would argue that the single most important one of those is the first one, the design and engineering, because that's where the problems get sorted out. That's where the process improvement really takes place, because that impacts the offsite manufacturing, the delivery, and the on-site assembly. So it all starts with the design and engineering. And hopefully now if I hit this video will run. So this is giving you an example of, and admittedly it's only a two-story home, but just to give you an example, in the United States, this was the first home being built by this builder using a fully integrated offsite system. So this house was 3,800 square feet, two-story. And you can see 3 hours, all of the ground floor walls are up. Now you start to see the floor cassettes getting set in place at hour 4. Now they're setting the second floor panels up. See, by hour 8 in the afternoon, that house is at plate level. Look at the lack of waste that there is around it. Look at the cleanliness of the site and the safety that's on the site. So that house was 3,800 square feet of frame space. And in 3 days, that home was through sheer inspection in the United States and ready for the follow-on trades. And that is that building after 3 days. Now you compare that with, typically it would have taken 15 to 20 days in California to frame that building if you were stick framing it. But more interestingly, I suppose, this case study I want to run through you again, which I think relates well to the costs. So this was a project of approximately 270,000 square feet of multifamily buildings in Northern California. So there were 232 and 3-story units, 272,000 square feet, 3 phases of construction. And the stick framing cycle time that was provided by our competitor to do this, going out using traditional framing methods in the United States, was 42 weeks to complete this job. And ours was 14 weeks. So you can see a dramatic, we're not talking here about a small incremental difference, we're talking here about a quantum difference in time frame on the job site, taking it from 42 weeks to 14 weeks. And what's important about this is that when we bid this job, the developer on the job who had used the previous framer before, who had said he could do it in 42 weeks, and I actually don't believe that he could, but that was the number that he gave. He was $100,000 cheaper than we were. So think about it. We went into this project $100,000 more expensive. But instead of arguing over cutting back on materials, we said to him, okay, we can do it in 14 weeks. Your framer saying you can do it in 42 weeks. What is that delta, that difference in 14 weeks versus 42 weeks worth to you? So, and I'll come to you now at the end. I'll give you the number that he actually gave us. But there are other improvements from using the offsite solution as opposed to just simply using a stick framing. He got a higher quality structure. He got reduced skilled labor, which in California, United States at the moment is a major issue. He had virtually zero waste on site, which saved him again a lot of money in terms of removing waste from the site, making it a more sustainable project. And he had reduced insurance claims. His insurer gave him actually, again, partly due to the fact that it was safer and he had less time on the job site. So he got reduced insurance, reduced insurance premiums. And he had no storage on site, which again, reduced the likelihood of pilferage or actually fire on the job site, which again, I think impacted on the insurance premiums that he was paying. So the savings realized. So remember now, we said we can do it in 14 weeks as opposed to 42 weeks, but we were $100,000 more expensive going into it. But the developer's figures himself, his own figures were that if we could do it in 14 weeks versus his 14 weeks, that would amount to a $600,000 reduction in costs to him. So think about it, $100,000 more expensive, but if we saved him that time frame, it was going to save him $600,000. So we put it to him that if he gave us the job, we would do it at the same price as the stick framer, provided that if we produced it in 14 weeks, that he would split the $600,000 with us. He keeps $300,000 and we keep $300,000. So in effect, we get paid $200,000 more than our initial asking price. And he agreed to it, and he paid it. And we then subsequently completed the second phase of that project, which was 172 units. And the third one is about to start in October of this year. And that one again, that was bid without a competitive bid because he sees the value and the speed from the offsite solution. Sorry, I know that was very brief, but thank you very much. Happy to answer any questions.
Wow. Thank you, Jerry. As always, very inspiring. I will always remember, if it is not a system, it is not a solution. So I really like this sentence. I will print on a paper to have in front of me on my desk every day. So, okay, we are at the end of this round of, we had 5 speakers presenting some projects talking about mass timber, and now you see all of them plus one. There is, I'm very happy to welcome Emma from South Africa, and I would like her to say quickly something about his PhD project, the one he is working on. She is spending a lot of time on these projects. Sorry, Emma, I'm tired too, so sorry for this mistake. So please, Emma, can you tell us something more about your experience, your adventure, and why you wrote this question, which should be visible for everyone?
All right, thank you so much. Thanks, Franco. Thanks, everyone. So on my part, my study is very much focused on the use of mass timber for more sustainable built environments in South Africa. And I'm looking specifically at how mass timber can actually contribute to achieving sustainable development goals. So in order for us to, of course, have some sort of impact using construction, um, the I somebody's talking. Sorry. All right. So the basically the idea is to look at the influence of mass timber on the four sustainable development goals that I'm looking at. So I think the first speaker talked about health and well-being. That's something that I'm looking at. I'm also looking at industry innovation and infrastructure. I'm also looking at sustainable cities and communities, and then of course just holistically how we can use mass timber to achieve the climate change agenda. So that's in a nutshell what my study is about. And I'm just hoping that everybody will please assist me in taking part in my survey. It will really help a great deal. Thank you.
Thank you very much, Emma. And we will share after, I know there is a survey, and we will share right after this conference. So we will share on LinkedIn the link to so you can all participate to this poll and to this survey and help Emma to complete this study. I really encourage you to do this. So we have a few minutes left, and we collected some questions from the audience. We are like we had to be multitasking here, collecting from LinkedIn, Zoom, WhatsApp, Telegram, etc. And we are trying to collect them all together and to present you the most interesting ones. You can see on your screen some of the questions, and one of them is here from South Africa. After seeing those buildings, my 9-year-old daughter has just declared that all buildings should be built of wood. Well, not all of them, because otherwise there would be a big shortage of mass timber timber in the world. But yeah, we will do our best to make real your wishes. Thank you very much for this note. I have a question for Jerry. Based on his presentation, there are some hidden costs in the mass timber industry, or in general in the building industry. I call them hidden costs because nobody is taking them into considerations. But at the end of the day, you cannot consider just the cost of the material in terms of price per cubic meter, price per square feet, etc. You need to take into consideration some those hidden costs. And I would like you to Jerry, to say something more about this.
Well, you mean sorry, when you say hidden costs, you mean the hidden benefits?
Yeah,
Franco,
the cost they don't consider when they compare
the benefits they don't consider. Yeah,
steel versus timber.
Yeah, I mean, I think this is the biggest challenge that all of us face in regardless whether it's mass timber or it's light wood frame prefabrication. These are some of the biggest challenges we always face in trying to have conversation. And in many ways, what I'd say also is that there's a lot. There needs to be a change of mindset among the people who are actually selling the product to the developers. I mean, we need to move the conversation away from the hard costs to actually what are the real benefits of the system. And again, it's back to saying, if it's not a system, it's not a solution. So why is the developer or the general contractor or whoever's involved in this, why do they want to use the system? Now, if it's a purely from an environmental perspective, okay, then somebody can help to try to calculate those. I can't really do the calculation on that, but I know from my own experience over 30 years in this, that the real reason why most of the people who are using off-site type fabrication methods is because they want to build that building more efficiently. Now, you can include sustainability in that as well, but more efficiently in terms of reduction in waste, reduction in labor, reduction in time frame. And at the end of the day, we all have to face this reality is, in the building industry, more so than any other industry, time is money. And what you have to do is get the conversation around to what are you saving them in terms of time relative to what other building methodology they would use to build that building. And then actually ask them, what is the cost benefit of saving that time? Now, I can't answer in terms of these high rises. I don't know. I'll give you a very real example of it is we have done enough polling of our customers over the years in buildings that are 4 and 5 story wood frame multifamily to understand that typically in California, a normal size 150 to 200 unit project, the carry cost for a developer on one of those projects is $20,000 per day. Right? So once you know that number and you're saying, if I can take every month you take off that project is now saved $600,000. So we always pull the conversation in that direction, not the fact that they're telling us, oh, you're $200,000 more expensive or you're $300,000 more expensive. It's to say, okay, you say we're that, but now let's talk about the reality of what the cost savings are to you of reducing that cycle time. And it's getting the conversation there. I mean, it's in many ways, this sounds very simplistic, but I think it's what people miss. They fall for the trap that when the developer or somebody comes to them and saying, oh, you're X thousand, $100,000 more expensive or $1 million more expensive, they fall for the trap of thinking, oh, I'll have to cut back on the materials or I'll have to do this and I have to do the other thing. But they don't actually go to say, okay, what's the time value of money here? Now, I don't know what typically the savings are from a mass timber building being built versus it being built in any other methodology, but I'm sure there are significant time savings involved. Yeah. Now, what are those time savings worth? Whether it's heads on beds, for example, so if it's rental or it's hotel or it's a building or it's an office block, you get people into that and you're generating revenue in it. What's that worth? The fact is, if it's also multifamily or it's residential type buildings, you're getting that construction loan converted, and especially in these times now, we're back to sort of, I'm going to say, higher or normalized interest rates. What's the saving of getting from your construction loan to your permanent loan faster, as well as then what's the cost savings of the reduced waste coming from the site? But you really have to focus in on those and not get pushed away in those conversations. You have to get the developer to put that number down, because if he's not willing to put the number down, then really he's not willing to do he's not willing to do the he's not willing to negotiate with you. It's not a true, open, fair negotiation. Because when you go to negotiate with anything with somebody, there has to be two sides to the argument. So he can't just be saying to you, oh, I want that building and you're $200,000 or $1 million more expensive. You have to be saying, okay, but on the other hand, here's the benefits I'm bringing. Now let's put those down the line and say, what are those worth to you overall of this project? And sorry, my final part on this is, you also have to be careful who you're negotiating with. Because typically, if it's the general contractor, you're going nowhere. You need to be talking to the money people, the developers, the banks, because they're the people who understand the time value of money. Because typically the general contractor just bakes in the reduced cycle time into his time frame already and gives you no benefit from it. So we would always spend a lot of time circumventing the general contractor to get to the developer, because it's his money that matters. And unless you're talking to the guy whose money is on the line, it's very hard to get an open and fair negotiation going.
I totally agree. It is a big problem we face almost daily. How much does it cost? Will it be more expensive? Will it be less expensive? And then I say, which parameters are we considering? How important is the time? If they don't care about the time,
but time is important. But Franco, but time is important. Time is important. No matter what it is, the point is, time is important. On a job site, time is important. So you have to pull the conversation around to time. And if you say to them, I can save you 3 months, 6 months, 7 months, and they won't give you any credit for that time saving, then I'm sorry, you're not dealing with a principled negotiator, because they're just looking to take everything from you.
Yeah. I don't know if there is someone else that wants to add something to this question. Otherwise, we move to the next
I would
question.
like, I'm not sure if you can hear me, but I would like to just
Yes, we can.
put in that
Yep.
some figures from Sweden indicates that there are, if we only consider big size buildings and compared to kind of the regular normal standard way to build a building using concrete and steel, there's a saving about around 8% on all costs when the building has been completed. So.
Well, it's a huge amount of money when we talk about big buildings. 8% means a lot. If you consider all the parameters, means that at the end of the day, you will go for timber, for mass timber. When you think about, should we go for concrete, steel, or mass timber? That's the choice. That's the right choice to go for.
But it varies
Good.
very
I will
much
move to.
depending on the system and
Sorry.
so on. But yeah, I'm just saying it varies very much depending on the system that you use, because you can also have larger savings. But in general, average it's 8% savings. So just.
Perfect. Thank you very much, Kenny, for highlighting this and from the Scandinavian countries. And there is another very interesting question, which is about the mechanicals, about the installations. And you can also find this question on the comments on LinkedIn. There was a question for Ricky. Given the impact that MEP services can have on mass timber structure, especially multi-level structures, how seriously, in your opinion, is the MEP industry taking the mass timber? I would like to add that in every large-scale mass timber buildings we worked on, we always had a lot of, I cannot say problems, but we had a lot of challenges to solve because of the installations, big ducts, HVAC system, pipes, etc. I'm not saying it's their fault. I'm not saying that, but it is a challenge we need to face because of the penetrations between timber, between beams and columns and those pipes. But yeah, if you Ricky can reply this question, please.
Yeah, yeah, it's a great question. I think because of time, I kind of skimmed through it at the end of my presentation, but there's a number of ways to integrate those systems in a mass timber building. But my quickly moving through those slides was not to try to indicate that that should be a quick part of the design process, because I think it's a very important part of the design process, and figuring out how, maybe in a typical sense, those systems would be designed after the fact, meaning, the structure and the architectural layout is done, and then you kind of have to figure out how to work those systems in and around. With mass timber, I think it should be part of that initial design process. So, figuring out what is the best way to route them to try to minimize penetrations, like we talked about. And there's kind of some more common trends that we're seeing develop. Very different trends in terms of laying out MEP in a mass timber building in a multifamily building versus in an office building, for example. But even within those individual sectors, some common trends that we're starting to see develop, where it could be, in multifamily buildings, spanning panels from unit wall to avoid having structure that was basically aligning with the corridor walls, so that there's no beams there, so that any systems that go from a corridor into each dwelling unit can do so without penetrating structural elements. I think that it's also there's more reliance on the architect and the contractor to understand where all of these things are being routed and laid out, so that there's more coordination with the timber itself. But we are seeing some MEP design firms, mechanical engineers, start to, I guess I would say, try to use their previous mass timber experience as a differentiator, among their competitors, just on the design side of things, where they do have several projects under their belts, and they're seeing the value in having that mass timber experience, and then trying to use that as a way to promote getting more projects. I think the biggest learning curve is on the subtrades, though. is in having them understand that it is a reduced scope on site because it's already been prefabricated where all of the systems are going to run. Openings and penetrations are already drilled and cut. So it's really just a matter of connecting elements together on the job site. So that's a learning process, and also the scheduling too. Like we've heard several mass timber projects where, like we just talked about, the schedule impacts of using mass timber or other offsite solutions are real. But if it's a sub trade's first mass timber project, we've heard some cases where they didn't actually think that the stated speed of construction was going to be realized, so that they weren't even on site, when the project was ready for them to go. So that's a problem. That's a challenge too. Is it's one thing to get the timber up quickly, but if the other trades aren't able to follow along and do their work at the same speed, then you've kind of created this quick part in the middle with a slow part on either end. So it really does, to Jerry's point, it's the system, and the system is not just the mass timber. It's the system is the entire integration of all the elements together.
Totally agree, Ricky. I love the word holistic. We need to have an holistic approach to our design, to consider the structure, installations, the design of the architects, and we need to merge them together. This is where, in my opinion, BIM proves how important it is. We can merge different models together. We can find the clashes. We can find and solve all the penetrations. Guys, there are a lot of questions, but we are running a bit late, so I don't want to stay here longer. But there are two questions. I think they are very important still, and then you will find all the other questions on LinkedIn, and we can keep this conversation on. There is a question from Christoph Hegemann about the robustness requirements for high-rise building. I can take this question because the robustness is something that is getting more and more important all over the world. Robustness means that when we talk about, when it comes to high-rise buildings, is what happens if we remove suddenly one of the columns. It could be one on the perimeter, it could be one internal column. We must avoid the progressive collapse, the total collapse of the structure. Yes, I can say that we are familiar with it, and we are implementing the robustness concept in the buildings. In the building I was showing at the beginning of my presentation, well, at the end of my presentation. It is an 8-story building which will be built in Denmark, and we designed all the connections in a way that one of the columns can be removed at level 1, 2, 3, 4, up to 8, and the building will be able to redistribute the forces inside, and in that way we avoid to have a total collapse of the building. Personally, I think this is something that all the building codes should consider for the next high-rise buildings. Another question is for Leander, and the question is, where are we in terms of standardizing design for residential buildings, for instance, kit of parts, plans for homes design? Talking about both low and high-rise building, and if there is a library out there that can be reused for the design of those buildings.
Yeah, that's an interesting one. I mean, I think that is something, when we look at the car industry, and it's funny that a lot of us relate to that industry, because of course this comes down to that fact. We all relate to our car. It's like a status symbol, and much more so we relate to our car than we relate to our house. The car industry also allows us to come up with individual solutions. So why, as a building industry, we cannot? And I think that's what we have to work on. It's of course something we also like in our development, because we are limited in terms of the logistics, the access to materials, which is far more limited in Africa than we have like in Europe or North America or even in Asia. Also when it comes to timber, we have to be creative with that, and we automatically start to build up these kind of catalogs for our projects. So we use similar grids for very different looking projects. If it's 4-story multifamily house or a row house with multiple houses combined, it's still the same elements we use for the construction of the two different types. So that's where we start to build like a structural catalog. And then we, on top of that, of course, have an architectural catalog where we look into window, we look into bathrooms, we look into other components. Like with a car, you can like look at the steering wheel, you can look at the wheels, you can look at the interior. There's like many different components you can look at, and also the car industry itself. If you look at Volkswagen, if you buy a Skoda or Volkswagen, it's on the same chassis. So I think this is something as a building industry where we have a lot to learn and a lot of like things we can still improve, especially to tackle like the affordable housing market where this will be needed. I mean, we can all design a great complete concrete villa or a complete mass timber house, but those will be very expensive because they take up a lot of resources and are individual solutions. So if we can make modular solutions, I think we can make a big stride forward.
Okay, well, thank you, Leander. The very last question is for Craig, because people were wondering how they implemented the DfMA in such a huge skyscraper made of timber. I'm very curious too.
Well, the whole premise of the prototype was DfMA, because you were not going to be constructing the CLT, the wood, on site. You were going to have to be bringing components to site and installing them. And to make it cost competitive, you had to use the value, as Jerry pointed out in that wonderful movie, of the speed difference between assembling parts versus assembling pre-manufactured components. So our components were 10 feet by 40 feet, which meant you could get on a truck, get it down a road, and a crane could swing it up into place. So the speed was significant. In fact, the only thing that slowed the process down from being faster was they still had to slip form the concrete core. So that was the driver of speed there. So, but that still sped it up, because ordinarily you're going to take 3 days to do each floor if it was going to be concrete and steel. So I think DfMA means you have a complete understanding and design of those component parts from the beginning. You plan it, you know what it's going to be, you know the cost of it, you know the how it's going to be assembled, all the routing, the CNC troughs are set up. So it is a run through very much like an automotive process where they go from one to another to another. So I think CLT very much is all about DfMA. You have to apply some sort of logic of understanding it from a digital model to being a real model in order to manufacture it. And you're not going to get to that notion of like a car assembly plant unless you're using DfMA. So it just, I should have talked more about it, but I was trying to get through the time. But it is a key. And I think I want to say one additional thing to Jerry's point about the 7 worst words, as we don't do that here, or that's not the way we've done it in the past.
That's the way we've always done it. Yeah,
that's the way we've always done it. I think that is a very, very powerful force of momentum, and it's hard to change people's way of seeing things. And even we're finding that even when you can show them a financial reason to change, if they haven't done it before and are not comfortable with it and haven't grown up with it, they're still very resistant. As someone once said, no one wants to be the first person, they want to be the second. They want other people to take that risk of doing that project the new way, They'd rather not take the benefit of the potential benefit of the time savings and the cost savings and the extra profit if they haven't done it, because they have a sense of personal risk of what happens if this fails and my name's on it. So I think it's a real challenge. But I think you're seeing this happen, mass timber happen so much now in every continent, that now the risk is, if I don't do this, if our company doesn't do this, we're going to fall behind and we'll be out of business. So there's a ratcheting up of a different sort of tension and fear. So it's the fear of being too new, but then it's the fear of being left behind. And I think the fear of being left behind is now starting to kick in. I'm in Ontario and Toronto area, and every single one of my clients, and I do colleges and universities and some healthcare, every single one of them in their RFPs now requires that we have mass timber or mass timber hybrid, because they want to be with it and showing their students and their occupants that they're using mass timber. They don't care that it's faster, and because they're institutions, they don't do I'm going to save $600,000. Well, the capital silo is different from the operating silo. Anyway, but all this is to say, I think that the momentum for where this is going in the right direction. The big challenge is the insurance industry right now.
If I may add to this, there's also
sure.
a change in mentality within the building sector itself, because now we talk a lot about automation and CNC cutting, milling, offsite production, so on and so forth. But in reality, what has happened this far, at least here in Denmark and Scandinavia in general, is that the design process isn't 100% done before we start building the building, because we are used to or common to that when we build, if changes happen, we'll just incorporate it as we go, because it's done on site. And now we make a completely other design process, doing everything digital, but still in the head of people, in the mind of people, they are kind of used to, we'll just change it as we go along the way. But we can't do that now, because everything is produced off-site and delivered to the site. So if we need to make changes, it will be awful expensive. And we realized, Franco, you can talk onto this as well.
I know exactly what you're talking about, Kenny.
Where we have a situation that people are kind of, okay, we'll just no, we won't just change alongside, because we are doing the 3D model right now, and this model goes into production so that we can deliver a brilliant, perfect product on site that you just need to put together. So there's a mentality change there also, not only the cause of habit, or what you say. And so
yeah, but I think also there is a change. There is, what I've noticed over the years is, you have to make the distinction between the first project that a new customer does with you and the second and third project. The first one is very much, as you said, they don't believe it themselves. They want to hold on to the old ways of doing things. They're like a kid in a swimming pool trying to learn to swim, but they're holding on to the edge. They're holding onto the bar at the edge, and they just can't let go of it. Even though they know their feet are floating, but they can't let go. But by the time you get them through the first job, where they don't take full advantage of the system, then by the time they get to the second and third job, I think you see a notable difference in the way they behave, because they also have bringing their own teams together. Because usually within these organizations, there's a lot of people involved, some who are bought into it and some who are extremely skeptical, and it takes that second and third job to get them to the point where they've actually seen the benefits on the first couple of jobs, and then I think you get a completely different reaction from them. Because it's been interesting to me over the years to watch this happen, but unfortunately, it is the case, as you just quite rightly said. It's difficult at the very beginning because they still want to hold on to the old ways.
We both, me and Kenny, are having this experience on a project, and I know how hard it is. We're almost there, but it is like a challenge to face every day, a new challenge to face every day. Well, guys, it is 8:22 p.m. Here in Italy. I know that in other parts of the world is You are almost at the beginning of the day, but well, thank you very much for your time. Thanks to all our speakers. Thanks to we had something like 200 attendees, virtual attendees. Also on this second edition of the DfMay, and I'm sure that there will be a new edition 2024. And I hope we will have new projects, new exciting things to share with you all. You will find, just a final note, the recording of this conference will be available just a few seconds after we close the event on LinkedIn, so we can keep asking questions. You can tag the speakers, and we can still share our experience about the mass timber. From our side, that's all, and I think we deserve all a big applause, and then we can close the conference. Thank you, guys. Thank you again.
Thank you,
done,
Franco, for
Franco.
hosting the event.
Thank you all. Have a nice day.
Take care.
Thank you. Bye-bye.
Cause I know that you are the one.